Hello everyone, today we will be demonstrating experiment number 7. The name of the experiment is Torque Speed Characteristics of DC Shunt and Compound Motors. We have two objectives today. Our first objective is to study the speed versus load characteristics of a DC shunt motor. And our second objective is to observe the behavior of a DC compound motor under loading conditions. Here is our experimental setup without the connections. Let us see what are the major components of our today's experiment. As you can see, in the right side of the figure we have the motor, and in the left side of the figure we have the connected mechanical load. This mechanical load is connected to the motor, and to control this mechanical load we have a control unit at the top of this figure. In our today's experiment, we have three parts. In the first part, we will do some preliminary measurements. As you can see in the figure, we have the multifunction machine. In our today's experiment, we will be using this multifunction machine as a motor. So here is the nameplate for this motor, and these are the data we have recorded from the nameplate. Now we will measure winding resistances of the motor. So the table shows the winding resistances of the machine we are using today. Here is a demonstration how we have measured the resistance of the winding E1 and E2.
Yeah, okay. Today we're going to talk about the torque speed characteristics of DC shunt and compound motors. So the setup here is about a DC machine, and this DC machine is going to be connected twice in a different manner. The first time is going to be a DC shunt motor, and the second is a DC compound motor. Both of them, in both cases, we're going to derive a load. Now, this is our load, which is basically a sort of pony brake. This device is actually the device that takes the load on a motor. What is the load on a motor? Is the pressure that we exert on the rotor itself of the machine. So once the machine is running at a certain speed, you put the pressure on it, and that's where the load is simulated here. So how are we going to put load on this machine? Now, there is a cable here, and this cable is going to connect the torque pressure from this device to actually being exerted directly on the shaft of the DC machine. So here, how we're going to have to control the torque. The torque is applied based on this. So this is the scale of the torque from 0 up to 10 Newton meter. And then we actually exert the torque based on changing of the controller here. This is how we control the torque, increase it or decrease it. So once you apply a certain torque on the shaft, the speed of the motor is affected, right? And that relation is important for design characteristics, for purpose of application, for purpose of industrial application. The torque speed characteristic is very important. Now, the motor, which is basically the one that gives the energy to carry out the load, which is the pony brake here, then its characteristic is important because that's how the display of the speed versus the torque is going to be displayed. So the first thing we're going to connect as experiment 1, the connection here is going to be for a DC shunt motor, and that has been actually taken into study for the previous experiment. And the second connection is going to be the cumulative compound connection for the DC machine. So cumulative, if I remind you about cumulative, it means that your fields, you have both type of fields, your shunt field and a series field. Cumulative. Now remember, cumulative could be additive or differential. So we're going to have to deal with one type this time of this connection here in this experimentation. So the overall objective is to display the characteristic torque versus speed for both type of connection. DC machine as a shunt and DC machine as compound.
In part B of this experiment, we will study the characteristics of DC shunt motor. Here is the circuit diagram. As you can see, the winding E1 and E2 are in parallel with the motor itself, so that's why we call it shunt motor.
Regarding experiment number 7, which is on the torque speed characteristic of DC shunt and compound motors, we will also calculate the efficiency for that. Now we have made the connection for the DC shunt motor as per the circuit diagram given in the manual, figure 1. And you can see we have the control unit. This was already explained, and we have made all the settings about the torque and M maximum and the mode of measurement, you know, and all these things are there as per the. Now temperature alarm also has been connected. You see, if the temperature exceeds, then it will trip and you will get a LED light will turn on, and then you have to, you know, reset that, you know, after making it cool for some time. Okay, so the procedure is as follows. Now we will switch on the motor supply, and we will increase the voltage so that we reach 2100 RPM, and then we will gradually start applying the torque, which is from this magnetic brake. We will start with no torque, that means no load, 0, all the way we have to go up to 0.25. But we have to keep in mind that the armature current should not exceed 4.8 ampere. So always we keep an eye on that, and accordingly we select you know, how much to increase it at every step. So let's switch on. Okay, now I am applying the brake. You can see it's a magnetic brake, so it will take a little time. Keep on rotating it till you see the torque increasing from there. Now you see the torque is increasing. How much is it now?
If you would like to see other measurement as we have defined in the KC software, you can come to this display option, for example IA and VA. This VA is our applied voltage and this IA is our armature current. After making the next connection, we will start do the measurement on the same KC file. We will not close it, we will keep it open. So how we'll do it, like the previous experiment, we come here and we press append new measurement series. In part C, we will study the characteristics of DC compound motor. Here is the circuit diagram. As you can see, the circuit diagram is almost same as the circuit diagram of DC shunt motor. The only difference is the winding D1 and D2 that makes this circuit compound DC motor.
Only one change in the winding connection. We introduced D1 and D2 for the compound, the series winding, so it's a short shunt. Okay, and the rest everything is same, nothing changes. We are going to repeat the same procedure now for the cumulative compound machine. So again we switch on and we increase the voltage
RPM,
and we will go to 1950 RPM,
65.
90, whatever value we started for the DC shunt, we'll keep the same value. Okay, so we will take the first reading at no torque, no load. Now we start applying the brake. Again remember, we will go up to 4.8 ampere.
Yes, slowly. Okay, it starts changing.
Take this.